My name is Jesse Elkins. I'm with ClimaGrow. I'm also with Elkins HVAC. It's one of the same right now. ClimaGrow is our nationwide company that's for climate control design. And our Elkins HVAC is the Washington regional HVAC company that we've been running. Jesse's had experience in HVAC for over 13 years, and the company has been up and running since 2007. So Jesse and I are co-owners of both Elkins HVAC and ClimaGrow.
Let me tell you, 11 years ago, I got a call from a high school buddy, and he said he had a little side project for me. He's found out I was in the AC business, so you can kind of see where that's going. I went over and did a little tiny, if I recall, it was a little 4-light setup, vented lights, and about 600 watts a piece. We did a little 1-ton air conditioner. I had no idea at that time what I was doing, but we started. A year went by, didn't hear anything, and all of a sudden another one called up, another buddy, and you can kind of see over the years how it developed. In the last year and a half, we've been 100% cannabis horticulture, with the exception of a couple of algae rooms that have popped up in the last year or two. We have done, we don't know exactly, we've done hundreds and hundreds and hundreds of grow ops, if not close to the 1,000 range. I wish I knew exactly, but something like that. In the last year and a half or so, we started actually documenting our jobs and taking pictures of our jobs. So we've got about 180 pictures here that you can just see kind of every aspect of it. We've done just about every type of grow op you can think of. Vented rooms, vented lights, and then most recently we're doing 100% sealed rooms and no ventilation whatsoever, just internal airflow. One of the reasons that the sealed room is popping up more and more is we believe that in this industry, in the medical industry, it wasn't up until the last couple of years that it started having to be tested for the product to be tested. We work with Northwest analysts, Northwest Botanical analysts, and they've informed us that just in the last year, approximately about 30% of all product being tested is being tested with is no good, basically due to mold, bacteria. We had a room that got tested for E. coli. Whatever the case is, it's that's what's happening with the sealed room transition. So the idea behind a sealed room is not letting any outside air come into the room whatsoever. If you take any outside air and get it into the room, you have the potential hazard of bringing anything dormant outside, and you bring it into a room that's you basically built for the perfect petri dish. You built the room to be the ultimate grow room. So you bring something in from out there and you bring it into your room and it's going to start growing. Most things outside you don't want to start growing in your room. So we're going to talk a little bit about the benefits of the sealed room and how we control the sealed room environment. For the most part, the sealed rooms we're doing for 502 they're using typically they're using around the 1,000 watts. Now with the Gavitas and the EPAFs, we've been seeing the 1150s pop up. So 1,000 watt, unvented, 100% climate control. So you're relying 100% on your air conditioner to keep up with the heat load. To give you an example, in a 30-light open bulb sealed room, if you turn the lights on for 10 minutes, you're going to be at 117 degrees on average. You add moisture and live plants into that effect, something that's giving off heat and moisture constantly, it'll go up a lot more. Unfortunately we've seen emergency cases where AC goes down and they call us up, and if they're not monitoring their room and making sure that the climate control stayed in spec, let's say for an example, last week we got a call from a smaller medical operation that called us and said that for 12 hours his monitoring system went down and he was not regulating it. A little 30 amp fuse popped on the AC system. He went down, his room was up over 130 degrees and 99% humidity, and he did lose his crop over it. Now that's the first time we've ever seen someone lose their crop. Typically, they'll catch it within an hour or two and they'll start turning their lights off to save themselves, you know, so that's the first time we've seen a loss of crop. How do you want to start off? Okay, so what we've learned over the years, to get back to my trial and error days, I had no idea how to calculate for indoor horticulture. If you go on Google and look it up, it's going to be 3.4 BTUs per 1,000 watts. It's a pretty watt. It's a pretty common known fact, and that's how we've always sized. It's called sensible heat load. In general HVAC, that's how any general HVAC company is going to size for these rooms. It's something called sensible heat load. It's just the energy from the fall versus BTUs to take the energy away, to cool it down. What we've learned in the small rooms, I believe the first time I actually learned this was on a 12-light sealed room setup. We put in what we sized for sensible heat load. He made it through about the first week of bloom. I believe it's somewhere between a week and 2 weeks. He called up and said, "Hey, the room is not keeping up." He was trying to keep it at 75. It was about 78. A couple days went by before I got there to check it out. He was up at 80 degrees. So what we saw is every week in transition in the bloom cycle. Every week is a different environment. As those plants get bigger, they have more energy, they have more moisture, they're putting off more heat. So every single week is a different environment for these rooms. And we learned real quick. What we did is we put in another air conditioner for it. It actually made it all the way through the end of the cycle by doubling the AC. We didn't know exactly at this time. This is 11 years ago, or 10 to 11 years ago. I had no idea what I was doing yet for horticulture. But we put another air conditioner in. He made it through. We went on to the next job. Well, 100 jobs in, I finally figured it out. My exact formula for this. So sealed rooms, 1,000 watts. Our exact formula is 5.5 BTUs per watt. We have rooms right now that we are in testing mode on just to prove this. And what we do is we put 5 tons of AC in a room with 11 lights on it. We make sure they're in the 8th week of bloom to give it the ultimate test on the room. And we actually go in and we put one more light in and hit 12. And that thermostat, what it does is it might maintain the temperature, but the thermostat never actually satisfies. And when I say satisfy, what I mean is it doesn't turn the AC off. Proper sizing, the unit should turn off and on. It needs that off time to cool down and cycle. What happens is if that thermostat never cycles, first off, if the thermostat, let's say you have it set at 75, if you hit 76, you're undersized immediately. That's the first hit. What happens, even if you're keeping it at 75 and it maintains that, what's going to happen is you're taking a piece of equipment that's supposed to last 15 to 20 years and you're overheating it. The absolute worst thing you can do on an air conditioning unit, on the compressor itself, is overheat that compressor. Once the compressor starts overheating, it'll literally burn up and you'll be out of luck. And unfortunately, it happens on between the 7 and 9 week cycle of bloom. That unit basically takes a dump and shuts down, and you're out. There's no easy fix for it. It takes a couple of days to order equipment in or order a new compressor to get the thing installed. So what it does is it takes your average lifespan of 15 to 20 years, and it'll bump you all the way down. We've seen equipment go out as soon as a year, and not just cheap equipment, but high-end equipment. It's just not meant for it. It has to be sized accordingly. So even if you're maintaining temperature for a week or for a year or two, eventually that equipment will fail, and it'll could equal a disaster, a loss of crop. And if you're big enough and you have a loss of crop, it'll be one of those I wish I did, size it from the get-go the right way. We stress highly on sizing, so our equipment lasts 15 to 20 years, and that's the bottom line. We put our name on every piece of equipment and every job we do. We don't want to install anything that's going to break down and give us a bad bill. Yeah. So in the last year, we started seeing a lot of pumping in CO2. For all this time, we've been seeing burning CO2. So you've got one big burner in the middle of the room and you're burning it and pumping in the CO2. It's uncontrollable, or it's not very controllable. It's in one space for a big room. It does not mix thoroughly unless, you have to have a lot of air movement to get it to work. So in the last year or so, we started seeing a big rise in pumping in CO2. Well, about a year ago, we were doing our first 502 project, and the guy asked us, hey, how can we get this we're pumping in CO2, how can we get this CO2 to be be more mixed in the room. And I just simply suggested let's tap into the supply run of the ductwork, and let's just force the CO2 through the whole room through the ventilation system. It only made sense. Well, he did that. Since then we actually developed a little bar that we stick into the ductwork that ejects it thoroughly all the way across the ductwork instead of just sprouting out on one side. We figured out exactly where to eject it in these big, powerful package units per se. There's a vortex. When it comes out of the unit and it hits the ductwork for the first time, it puts a vortex, a spin on that air. We figured out, kind of just by trial and error again, where to put that to get the absolute best CO2 mixture at. I can't tell you exactly what parts per million. That's up to the growers to decide. We see everywhere from 1,200 parts per million to 1,600 parts per million. By pumping in CO2, one factor that we figured out is you can rent these 750 and up gallon stainless steel tanks, and they bring them out on site. It's roughly about $200 a year for the rental cost. Well, then you're buying CO2 in bulk, so you don't have to run to the store anymore and buy a little 40 or a little 80 and get them filled. These CO2 companies come out and fill it, and since you're buying in bulk, they're actually getting down to the price of basically buying propane anyway, or natural gas. Not so much natural gas, but definitely propane. So it's getting down to the same price range of burning. CO2 is a better mixture. It's cleaner, and you don't have to worry about that extra 12,000 BTUs of a burner. So you can actually lower your AC down a little bit by not having all these burners in the rooms. So we've been highly recommending to pump in CO2 dispersion. And that 502 customer that we did the first job for, he swears by it. He loves it. He's a third generation grower. He said it's the absolute best product that he's ever put out. He has the highest CBD. He does CBD and THC. He strives for both. The numbers are. He said it's the best he's ever done in his experience. The product just looks absolutely beautiful. Mr. Spliff, can you explain to them real quick what a beautiful product would look like, smell like, that sort of thing?
So the one thing to remember as everybody gets going is there's a bunch of product out there. If it does not have the appearance, if it does not have the smells, the things that really make it truly majestic, it's going to sit right where it grew. It's never going to leave that room. Nobody's ever going to be interested. So CO2 allows the plant to expand, to create more oil, to really run uphill without a sack of rocks on its back. It allows it to drop those rocks and perform naturally. And without it, a lot of plant expression doesn't happen. And so when it comes to environmental control and CO2 regulation and proper mixture, if it's not perfect, it's not right. And you are banking on things that are such big variables that you can never be exact. And CO2 it's a warm blanket for a cold night for a plant. It really allows the plant to function. It's already in a room of control. We're not outside, right? So if we're going to control, let's control to the very end point. And CO2 with good mixture and proper dispersion, there are variables, right? Let's control them all. And so you can't say enough about being ahead of it and being oversized on your AC, because when that goes out, I don't care if you have one light or 100 lights, you're dependent on that crop. Be it for yourself or somebody else or a contract you have, there is no amount of insurance that's better than environmental control. And really, CO2 and temperature and humidity all come together in one piece, and you cannot overlook it. And you really need somebody that knows what they're doing. A lot of people are going to undersell you and give you price, and really what you need is professional grade. Perfect. Perfect is the only way. I cannot stress that enough. So, yeah. And that's exactly it. There's a bunch of people that are going to do this. Perfect. You want people to see this product and be amazed, and it's very easy to get there when you manage certain variables. So I cannot stress environment and just general atmospheric control. So do not go the easy, cheap route on that. It matters more than anything. You don't want to go on a sunny vacation and have it rain the whole time. I mean, I don't know how to put it as basic as possible, but really CO2 enrichment, proper disbursement, I mean, they're very easy things to achieve, and with pumped gas, you don't have a flame that could go out. A lot of variables that I don't want to deal with, especially when people's lives it stops or it stays. Sorry. So you want to do it right, you've got to do it properly, and you've really got to have perfect environmental control. And CO2, you can have it stuck in a corner, and one part of the garden's thriving, and what am I doing right over there and not over here? So pockets are variables. Control them.
A lot of people think that I would sell. You think I was up here trying to sell CO2 systems? I actually do not. I don't do anything. We don't even charge any extra to pump the CO2 into our ductwork. It's just part of our job. But the bottom line here is, I need all of you to be 100% successful. My success is based on my customers, and if I can help you, guide you in any way to be 100% successful and keep you around for the next 15, 20 years or longer, then we stay in business. So that's the bottom line, and that's why I on these CO2 systems, that's why I preach CO2 and that all comes back down to the sealed room environment. For years, everyone's been venting their rooms and bringing in natural CO2, and it works great. The problem is with today's testing facilities and finding all the 30% range that can't even be used or made into oil. That's why we're saying with sealed rooms you have to have the CO2 as well. I'm going to let Jeremy explain some airflow issues real quick.
So some common questions and scenarios that we run into is proper air circulation. So the two main type of systems that we see in operation right now are either ductless mini splits or forced air package units with spiral ducting. Both are considered to be commercial, light industrial, heavy commercial, which is that 502 medical range. But there's some pros and cons to each type of system. Honestly, it just depends on the scenario. We will recommend a system based upon the application that it's going into. So we take a look at a room and we look at the dimensions, the square footage. Ideally, mini splits have been working very well for us in the past for medical operations, and that being because the rooms have been a lot smaller. So you take a room that's 10 by 10 and a 10-foot ceiling, and you can put a couple air handlers in there, and let's say you've got 11 lights and you're running 5 tons. You can have a 2-ton mini split, a 3-ton mini split, and then single zones and have an indoor air handler across from each other, and that works very well. The reason being is because it's a much more tighter controlled environment because you don't have much square footage. You're trying to spread that proven BTUs across the rooms. Oftentimes what we'll see in a little bit larger setup is that we run into issues with mini splits. Even with a 10 to 12 foot ceiling height, which is ideal for mini splits, if you don't have good, proper air circulation in the room to move the cooling BTUs around, and more importantly, to get the hot air off of the plants where the lights are hanging, maybe about 117, 130 degrees out there, over by the top of the indoor unit, it can be 70 degrees. The air sensors, the temperature air sensors are built in the side of the ductless mini splits. And there are add-ons to be able to run a 16-foot extension cord off the unit with an external temperature sensor. And we've had better luck with that because we can put it right in the middle of the room and get a cube of one and take out the average between them. And that keeps you good at your temperature range, say 75, 76 degrees. Where this does not help is in a room that's about 25 by 50 or something along those lines. Something that's a little bit more of a 502 applicant, where you've got about 32 lights in the room. Mini splits have a hard time keeping up for a couple of reasons. One being they're located on the outside of the wall. They do, depending on the brand that you have installed, they can inject the air about 14 feet off the wall. So the supply is not the issue because you can get 3, 4, 5 indoor units all running off of one outdoor unit or a couple outdoor units, and you can get 14-foot throws across the room, which is pretty good for most rooms. The problem is getting the air back. So the return is on top of the unit and the supply is on bottom and the fan is pushing the air out. To get the air back across the room, it's very difficult, even with wall fans. We'll go into a room and you'll see an 18-inch wall fan every 4 feet, 2 or 3 in between a mini split indoor head, and even with that, you still have iced up coils. The reason being is because it's trying to cool down the room, but it can't get the hot air across the coil fast enough. So you have refrigerant running through the coil, going out from the outdoor unit to the indoor unit. It thinks it's trying to bring it down to 75 degrees, but really you have 70 degrees air going through there, and it should have about 100 degrees air going through there. that causes an ice maker every single time. We get calls all the time about that. Not necessarily the systems that we design, although we have been there in the past, but we learned our lessons. But other people who have HVAC companies come out and install these mini splits and not take that into consideration because they're going off of square footage. The typical mini split for a home is sized off of square footage of the house. You can have a 1-ton unit in a living room, and it can do a 10 by 20 room no problem because you don't have, well, 130, 150 degree HID lights hanging in. So that's a big issue. Well, one way you can kind of solve that, if the room's not too large, is by doing just a lot of air movement through, fans bringing the air down and up and from up the top, and just really try to mix the air. The best way to describe airflow is to think of it as water. So you've got hot water, you've got cold water, and you want to mix it together to get lukewarm water. The only way to do that is to stir the pot. It's the same way with air movement. You can have hot water over here, cold water, but if you don't mix it, it's not going to do anything, and it causes issues for your plants and for your equipment. Now, where we've been headed with 502 is with the package units and the ducted systems. We love the forced air systems from 502 because you can have a room with 25-foot ceilings, you can be 30 feet across by 75 feet wide. It doesn't matter as long as you size the ducting appropriately for the room, not only the square footage, but also air distribution for getting the air into the middle room. The air coming out of a package unit is 10 times the CFM out of an air handler. So basically, you get 100% saturation out of the ducted systems. And we tell customers all the time, depending on the manufacturer of the product going in, the price is about the same. The equipment for mini splits is a little bit more expensive because it's 22 SEER, very high efficiency. The equipment for the package units is a little bit less because it's only 13 SEER. It's a little bit older technology, but it's built like a tank. It will go forever. So they're both great systems, but ductwork and labor and time and materials to install a ducted system equals out to the same as the equipment and less labor on a mini split. So really they come out to about the same price. So either one is great. You just have to take into consideration your room setup and how you want to distribute your air because that's a big factor not only for CO2 disbursement, so that you don't have hot pockets, because the last thing you want is to have an AC running on the wall doing nothing for your plants underneath the lights. So that's one thing that we definitely preach. And you can get away with, you don't have to go with a very expensive ducted systems. We can put in systems, other people have put in systems that we see, customers have put in systems, they're just bare bones. You don't need grills and diffusers if you don't want to. It does help little factors here and there, but all that does add up and it does equal cost. The main thing is sizing the equipment appropriately, measuring out the room, figuring out what application is going to work, and then applying the system best fit for you.
Sure. You can hire a lot of people to install an air conditioner. The biggest problem is somebody that's going to really look at your room with experience in this trade. You can have tons of fans on the wall, moving air, but if they're fighting each other and you have turbulence that's building, again, you have pockets and variables that will affect you. So it's very important to go with people that really understand the industry. There's people that will try to sell you on 10% or 20% or this unit or this ideal, but it is so important that your environment is properly managed. I cannot stress this enough. If you're going to go out and try to do it right, it's very easy to say, oh, I've got air conditioning, I've got a fan, and I've got CO2, and why doesn't it work? Because it's not a system. If the air is fighting each other and things are going all over the place, there's really no harmony, and harmony is what it's all about. And in the garden, harmony is absolutely paramount. So it's very important to understand that it's not just about having the right sized unit and having fans, because you could order that anywhere. It's about having people that understand that exactly and being able to bring your project to life and not just install something and walk away and call when you need service. You need somebody that's going to set you up and actually care their name is on it. They want your garden to work. And so it's very important to understand that when hiring somebody to install or to work with you, that they understand these challenges and have been through it. People come into gardens and are like, oh yeah, I can do that for you. And then they've got to come back and fix that guy's work because they didn't truly understand all the variables. So I really urge you to think about that before going and linking with somebody is, what experience do they have with these variables that can change everything? Harmony. So just food for thought.